Let me explain insertion sort with a simple cards example, with simple playing cards. So it's a simple example but very effective in understanding how insertion sort works. So basically insertion sort means you pick one element and you put it in its right place when moving to the left. Okay, let's take for example, we have 3, 6, 2, 5, 4, 7. Okay, then now let's pick 2 here. Okay, let's see what happens here. So while moving to the left, put it in its right place. Now our aim is to sort this in an ascending order. So let's see how this works. So you pick 2. To its left, what is it? 6. So 6 is definitely bigger than 2, and since we are aiming for ascending order, now 2 will shift to here. Okay, now still there is plenty of space left to the left. I mean, yeah, there is still space to move to the left for element 2, and now since 3 is bigger than 2, now we will move to here. Okay, now let's pick another element. So this is how insertion works. Basically you pick element and while moving to the left you put that element in its right place. So what will we do during insertion sort algorithm is, so from start to the left. Okay, now at the very beginning we'll pick 1. Okay, because if you pick the first element, and even if there is only one element in the array, it is sorted, right? So now let's put this back here. Now let's see how the example works. So first of all, you pick 3. Okay, see, even if there is only one element in the array, it is assumed it's sorted because there is no comparison to any other element. Now let's see 6. Okay, while moving to the left, so we have to compare all the elements to its left until we get the right position. Okay, now let's see 3 is definitely smaller than 6, so it is sorted. Now we pick 2, so 2 will come here and 2 will come here as discussed before. Okay, now currently we are at the third element. Okay, 6 is definitely bigger than 3, so we'll ignore it. So since we are sorting from left to right, so at any given position or wherever we start, so the left side of its array is all sorted. Okay, so now we did 3. Now we did the second position. No, previously it was 3 and 6. Okay, so our first 2 elements are sorted already. Now we pick 2 and we put it in its right position. Now all these 3 are sorted. So even when we found, for example, let's say 6 and 3, no need to check beyond 3 because it is sorted. Okay, that's why we can stop here, so we can save a little bit of comparison overhead for us. Now let's pick 5. Okay, now 6 is definitely bigger than 5, so we put it in its, we swap it so that we can put it in its right position. Now 5 is here. Now 5 is compared against 3, so they are in their correct positions only, so we can stop here. Now 6 is done. This part is sorted already. Now let's pick 4. Now it is definitely less than 6. We get like this. Okay, and now 4 is compared against 5, so it will go here. The 4 is in its right position when compared to 3. It is in its correct place, so no need to further compare. Now until here is completed. Now if you see 2, 3, 4, 5, 6, 7, the array is sorted. So this is how insertion sort works. Code will also be very similar. If you work through one example, you will be able to write it from scratch anytime without needing to remember any code. So insertion sort is very simple, and in fact it used to be one of the first algorithms taught at MIT Algorithms course. And even if you open the book Introduction to Algorithms, CLRS book, very famous book, you will see insertion sort as the first example. It's a very simple intuitive algorithm, nothing to be worried about. We will discuss code further.